Okay, we're going to start with a simple review of the word problems that are found in section 9.4 of your textbook. And these are max and min problems or revenue problems or any problem that is requesting or requiring that you find the maximum point or minimum point of a quadratic formula. In these problems, I'm going to have a quadratic function that's going to be represented by a parabola, and that parabola is going to give me some information. When the parabola opens up, it's going to give me a vertex point at some x and some y that is going to be the smallest point on the parabola. Remember, a parabola has a lowest point and a highest point depending on whether it opens up or down. So when it opens up, I have a minimum point. And when it opens down, I have a maximum point at some x and some y. And so what we're just looking for is the vertex and the information that's given to us from that x and that y. I'm going to start with example 8 on page 572 because the setup and the work is done for you on there. You can listen to my example and follow along with what is in the book as you're taking notes. Finding the maximum revenue. For a revenue problem, revenue is the same thing as income, sort of, and revenue equals the cost per item, or the price you sell it for, times the number of items sold. So what's going to happen with these? With the cost per item, they're going to give you a funky expression that represents the cost per item that has a bunch of factors that aren't really important for you in here. Okay, and so it's going to look a little crazy, but just take it at face value, and then next week when we talk, I'll explain to you kind of where they get some of those values from. All right, let's look at example 8. An electronics firm manufactures a high-quality radio. Over the past 10 years, the firm learned that it can sell X radios at a price of 200 minus 1/5 X dollars. So this is what I mean by the price per radio is a little funky looking. It's 200 minus 1/5 X dollars per radio. That's the cost per radio, where X is the number of radios sold. Okay, it's not going to make a whole lot of sense why this is the cost per radio, but that's okay. And so now we need to set up our equation. I'm sorry, let me finish the problem. How many radios should the firm manufacture to maximize its revenue? Find the maximum revenue. Okay, so now we need to set up our revenue equation. So revenue equals cost per item times the item sold. In this particular case, we're going to try and sell X radios at a cost of 200 minus 1/5 X dollars. Again, don't worry about that cost per radio if it doesn't make a lot of sense. In this example, I don't have anything being squared just yet. That's my clue that I'm going to need to distribute that x in there so that I can actually reach my quadratic equation. Right now I have a product, but that product I can't solve for anything. I can't figure out what the vertex is from this product because it's not in standard form or vertex form. So just like anytime we're graphing, we need our equation to be in either standard form or vertex form, and this one is in neither. So now what I'm going to need to do is I'm going to need to distribute in order to get it into standard form. That leaves me with R equals 200x minus 1/5 x squared. By putting this in true standard form and descending from the quadratic term, I get R equals negative 1/5 x squared plus 200. In this case, A equals negative 1/5, B equals 200, and C equals 0. The next thing that I'm going to do is find the vertex. I know from the value of A that my parabola is going to be wide and it's going to open down. What that tells me is I'm going to have a maximum point for my vertex. Okay, so now I just need to solve for the vertex. The x-coordinate of the vertex is equal to the opposite of b over 2a. That's the opposite of 200 over 2 times negative 1/5. 2 times negative 1/5 is negative 2/5. Remember, dividing by fractions is as easy as pi. Flip the second fraction and multiply. And so I'm going to multiply 200 by negative 5/2. A simple simplifying of this fraction, 200 divided by 2 is 100. Negative 100 times negative 5 is equal to positive 500. And so that gives me the x-coordinate of the vertex. Remember, when I need to find the y-coordinate of the vertex, I have to plug what I got for x back into the original equation. So I'm going to do negative 1/5, and then x squared will be 500 squared, plus 200 times 500. Squaring 500 isn't bad. I'm just going to square the 5, that's 25. And then squaring those 2 zeros is like squaring 100, so it becomes 4 zeros. So 500 squared is 250,000. 200 times 500 is 10,000. Okay, and now I can just simplify this. 250,000 divided by 5 would be 5, 0, 0, 0, 0. And that's a negative value. Plus 100,000. And I have 100,000 minus 50,000, which leaves me with a positive 50,000 as the y-coordinate of my vertex. Okay, so what does this vertex point mean? 500 and then 50,000. What that means is for every 500 radios I sell, I will maximize my revenue in dollars at $50,000. So I should sell 500 radios to get a maximum revenue of $50,000. And that's the statement that you would write. Okay, now go to page 576. And we're going to first look at question 55 and 56. They go together. I'm going to go through this just a little bit faster. A company has found that it can sell X TVs at a price of $450 minus 1/6 X. How many TVs must the company sell to maximize its revenue? And so here, the equation is going to be R equals X times 450 minus 1/6 X. So this is where X is the number of TVs and 450 minus 1/6 X is the price that they sell them for. Because my equation right here is not in either standard form or vertex form, I know I need to distribute. That's going to leave me with R equals 450X minus 1/6 X squared. I can look at this equation and decide what A, B, and C are. You can put this in descending order if you want. I'm not going to. And so A is negative 1/6, B is 450, and C is 0. Now I'm ready to find the x-coordinate of the vertex. This coordinate will tell me how many TVs will maximize my revenue. So I know just by looking at this equation, because A is negative and a fraction, this is going to open down and wide. So I know my parabola is going to look something like this, and it's going to have a maximum point, and that's going to be where my revenue is maximized from this number of TVs along the x-axis and from this amount of money made from those TVs along the y-axis. And so now I can find the x-coordinate of the vertex. That's the opposite of b over 2a, which is the opposite of 450 over 2 times negative 1/6. Simplifying that denominator, I get negative 450 divided by negative 2/6, which is the same thing as negative 1/3. Remember, dividing by fractions is as easy as pi. Flip the second fraction and multiply. So we're going to multiply negative 450 times negative 3 over 1. And the x-coordinate of my vertex equals 1350. And so this answers question 55. How many TVs must the company sell to maximize its revenue? 1,350 TVs. Now let's answer question 56. Question 56 says, what is the maximum revenue from selling that number of TVs? I need to take my x-coordinate of the vertex and plug that into the original equation. And so I get 450 times 1350 minus 1/6 times 1350 squared. For this one, for sure, you probably want to use a calculator. Plugging all those good numbers into a calculator, you should get 303,750 for your y-coordinate of the vertex. Remember, that's dollars. That's the amount of revenue. And so the y-coordinate of the vertex would be $303,750. Okay, I'm going to complete one more problem, but I wanted to point out on question 61, selling vases. It says a glass works that makes crystal vases has daily production costs given by this function, and it's C of x equals 0.2 x squared minus 10x plus 650. And so this is an example of an equation that is already given to you in standard form, and so all you would need to do is identify A, B, and C. There's no distribution that you need to do here. And then it goes on to say X is the number of vases made each day, how many vases should be made to minimize the production costs. So you know, because A is a fraction and positive, that it's going to open up, and so now we're looking for a minimized cost, okay, which is going to be the vertex because it's minimal on the bottom. Okay, the one that I want to solve is actually number 62 because it's a little bit different. From the top of a building, a ball is thrown straight up with an initial velocity of 32 feet per second. The equation h equals negative 16t squared plus 32t plus 48 gives the height of the ball t seconds after it is thrown. Find the maximum height reached by the ball. And so if you remember, we did our vertical motion model a while back, and we talked about all the different parts of the vertical motion model. But what this is saying is t is time and h is the final height. And so it's asking what is the maximum height, or what's the vertex of the parabola that is created from throwing this ball into the air. This is already in standard form for us, so all we need to do is start by identifying A, B, and C. So A equals negative 16. B equals 32, and C equals 48. And I'm going to go ahead and let you guys pause here, and then when you come back, you'll get to see the solution to this, trying to find the vertex. Okay, check out the rest of this solution. The ball hits a maximum height of 64 feet after 1 second. So make sure this is clear. Get some studying done, do a few extra problems, and email me if you have any questions.